Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series. Here we are discussing each chapter concept wise, and once the chapter is over we are also discussing previous year question papers from that chapter. So we have already completed two chapters, electric field and electric charges. Yesterday we have discussed electric field and electric charges previous year question papers. Today we are going to discuss the previous year question papers for the next chapter that we have completed, that is electrostatic potential and capacitance chapter. Okay, if you have not seen our previous 4 lectures that we have done in this chapter, you can go and check in our playlist that will be given in the end of the video. And also, if you are interested in KCET 2025 exam, we are also going running a weekly test for free weekly mock test. We have started with physics and then we will continue with other subjects as well very soon. So you will get the notification. If you want to get the notification, you have to join our WhatsApp channel. The link is given in the description below. So don't forget to join our WhatsApp channel. There we will get you will get all the information related to KCET 2025, as well as you are going to get the test paper questions, mock test questions for KCET 2025 that we are currently running. Test 1 is already completed. Mention in the comment if you have appeared in that test and how much marks you have scored. So now let's moving on. We are going to discuss previous year questions from the chapter electric potential and capacitance. Let's move on with the first question. Uniform electric field vector E exists along the also one more thing I forgot is that the question paper, after answering each questions, the PDF for that will be given in the description. You can download that PDF and see the questions and then try to answer it yourself. Then you can check this video for detailed explanation. Okay, a uniform electric vector E exists along the horizontal direction as shown. The electric potential at A is VA. So electric potential given at A is VA, and electric potential small point charge Q, small charge Q, from here it is been moved in this path to point B. Okay, slowly along the curved path as shown in the potential energy of the charge particle when it is at point B. So what is the potential energy of the charge particle at point B? So what is given? Electric field is given, constant electric field is given, and the displacement Ex is given. So what you have to do, you have to calculate the work done, the energy of the charge particle, not the work done. To solve this problem, first we have to calculate the work done to move this particle from here to here. If we can calculate the work done, then we can find the potential energy at this point. Now we know that potential energy of a point is basically nothing but the charge times potential. So if the charge is Q, then times VB will be the potential energy of the charge at this point. So Q times VB is the charge at this point, and we are interested in finding the potential VB. Now we know that work done is basically Q times final potential minus initial potential. So if we can calculate the work done, then we will be able to find this potential energy. So from there you can write this QVB is basically W plus QVB, VA. Sorry, this is not B, this is A. Final minus initial, right? So initial is A. This is what we are trying to find. Now if you see that we are moving the charge is positive, and we are moving the charge in the direction of electric field. So if we are moving a charge in the direction of electric field, then this work done must be negative. If we can calculate this work done, then basically our life is sorted. Now what is the work done? So work done basically when you are moving a charge in an electric field, what is the force? So first of all, the work done is negative because it is moving in the direction of electric field, right? That is, the work is being done by the electric field, not by external agent. So as I said before multiple times, that if we are doing the work, our value is there, that means it is positive. If the system is doing the work, that work is negative. Now here the charge is being moved by the system itself, we are not moving, and the work done is independent of the path. That is also important. Now what is the force acting on this? Force acting on this Q times E, right? Force on a charged particle is QE. Now what is the work done? Work done is force times displacement, right? Force times displacement. In this case, displacement is x, right? It is x. Displacement is given x, so we can see the work done is QEx. So QV, the final potential energy, will be minus QEx plus QVA. That is, if you take Q common, it will be VA minus EX, right? So Q times EX minus VA, this is the final potential energy when it is at point B. Okay. Now, a parallel plate capacitor of capacitance C1 with a dielectric slab in between its plates is connected to a battery. It has potential difference of V1 across its plates. When the dielectric potential difference are C2 and V2 respectively, then so when the dielectric is removed, okay, when the dielectric is removed, the potential difference are C2 and V2. Now you have not disconnected the battery. Now here they have mentioned that the battery is disconnected, so definitely V2 and V1 must be same, right? So initially it was between the plates V1 and V2, so V1 and V2 must be same. So what we can say that V1 must be V2, that is the first point, since battery is not removed. Now dielectric slab is removed. Dielectric slab removed means capacitance decreases, right? Capacitance C1 is basically K times C2, right? So if you remove the dielectric constant, C2 must be less than that of C1, and that is the times of the dielectric constant. So if dielectric constant was 2, then now the capacitance is half of that whatever was there before. So definitely C2 is less than C1. Okay, now let's see the options given here. Option given here is V1 equals to V2 and C1 is greater than C1. So correct answer is option C. Okay, let's move on. 5 capacitors of each value 1 microfarad are connected as shown in the figure. The equivalent capacitance between A and B is. Now this question I also given as a homework. Again we are going to solve that in our next lecture, where we are discussing the homework problem, but this is also came in KCET previous year question. So what is the meaning of that? So now if you see this diagram, you will see that these two capacitors, do you get anything familiar? Anything which is familiar to this? So if you are not yet able to solve this, you should know that this is called Wheatstone bridge configuration, which we are going to study in current electricity chapter, very important part. And this is a Wheatstone bridge configuration. In Wheatstone bridge configuration, if the ratio of the resistances for these two is equal to ratio of this resistances these two, then there is no current passing through this capacitor. Basically these 2 points are at equal potential, equipotential, right? So you can see that all the capacitors are given 1 microfarad, right? 1 microfarad. 1 microfarad for less complex problem. For JEE problem or advanced JEE problem, maybe they will give you the values where the ratio is constant, but they are not all equal. So in that case, what you have to do, you can simply remove this capacitor. You can simply remove this capacitor because they are in Wheatstone bridge configuration. So if they are in Wheatstone bridge configuration, you can simply remove whatever is in the middle, right? So that is the equivalent circuit. Now equivalent circuit will become 2 capacitors, first 2 capacitors in series, then rest of them are in parallel. Now you should remember that if 2 equal capacitors, 2 capacitors C and C, if both have same capacitance and they are connected in series, then their equivalent capacitance is basically what? If you know, let me know. It is C by 2. Equivalent capacitors, when 2 capacitors are equal, are connected in series, that is C by 2. This is a shortcut method. If you know this, you use it. Otherwise, you can use the law that is there, but that will be very longer. Okay, because you have less time to answer this kind of questions, so you have to use a little bit of shortcut and tricks. The trick is that this is 1 microfarad, this is also 1 microfarad. Okay, then this is also 1 microfarad, this is also 1 microfarad. So the equivalent will be 0.5, half of 1 microfarad, right? So 0.5 microfarad, and then another 0.5 microfarad. They are now in parallel. Now parallel, they gets added. So the final answer is 1 microfarad. Now everything, whatever I am doing in this, you have to draw this in this diagram. First you have to cross this. Okay, these two are in series. These two are in series means 0.5 microfarad, 0.5 microfarad here, 0.5 microfarad here. Then they are in connected in parallel. Parallel means they will get added. Added means 1 microfarad. So you can just simply solve it using this diagram. As soon as you realize this is a Wheatstone bridge circuit, so simply you remove this circuit. You check. Okay, they are. This is ending at here, so that means they are in series. If they are in series, simply 0.5. They are also in series, that is 0.5, 0.5, 0.5 getting added, 1 microfarad. Correct answer is 1 microfarad. Actually, it takes less than 10 seconds to answer this question. Now let's move on to the next question. The electric field and the potential of an electric dipole along its axis vary with distance r respectively as. So this is a very common question. Electric field varies 1 by r cube and potential varies 1 by r square. So you have to be careful what order they have asked. So first is electric field, second is potential. So electric field is r cube and potential is 1 by r square. Okay, so correct option is option C. Two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges. Two charges, they are unequal, so potential won't be 0. But you have to calculate that. Two charges, one is 1.8 microcoulomb, another one is 2.8 microcoulomb. Okay, they are separated by a distance 40 centimeters, so midpoint will be 20 centimeter from this side and 20 centimeter from this side, and they have asked you to find the electric potential. So we know that K, Q1 both are at same distance, so let's say R is the distance plus total potential is K, Q 2 by R. So you can simply take K by R common and it will be Q1 plus Q2. This is the simpler way, though you don't need to do write all the variables from the beginning. So final answer is K is 9 into 10 to the power of 9. Distance R is 20 centimeter in this case because it is half. So 20 centimeter, be careful, don't use 40. Almost 2.3, let's assume this is 2 for now. Okay, so 2 times 19 is 80. Okay, obviously it is more than that. We will see that. First of all, let us calculate the 10 to the powers. So 10 to the power of 9 minus 6 is 10 to the power of 3. Minus 2 will go up and it will become plus, so it will become 10 to the power of 5. Right? So 18 times 10 to the power of 5. Let's see which one is the closest. So let me rewrite the potential. V equals to 9 times 10 to the power of plus 9 divided by 20 times 10 to the power of minus 2, and this will be 4.6, and since they are microcoulomb, we have added 10 to the power of minus 6. Okay, now let's calculate the 10 to the powers first. 10 to the powers will be 9 times 4.6 divided by 20 times 10 to the power of 9 plus 2 minus 6, that is 10 to the power of 5. So 9 times 4.6 divided by 20, and we can remove the 0 and make it 10 to the power of 4. Okay, so this is the basic thing. Now let's see what will get the answer. So it will be almost 2.3, and if we take the approximated value, it will be 18 times 10 to the power of 4. So what is the answer? Possible answer could be 2.1, but 2.1 has 10 to the power of 5. So what you have to do, you have to take it 1.8 times 10 to the power of 5. So our approximated value is 1.8 and the closest value of that is 2.1. So you don't need to worry that your answer is not exactly matching. If you are using a calculator, you can get the exact value, but in the exam you are not using the calculator, so you have to use the approximated value and the closest nearest value, because now you have to be mindful at what you are doing. You are reducing it, that means the answer will be more than that. If you are increasing it, then your answer will be less than that. So this is the basic logic that you have to remember. In some cases, suppose it was 2.7. So if it was 2.7, then we approximated it maybe 3. So 3 9s are 27, right? So in that case, answer will be less than 27. So maybe answer will be 25, like that. So you have to be careful, you have to be mindful that what you are doing. But if you are doing it correctly, 99.9% times you will not face any difficulty. Some cases, some critical cases where all the options are very close to each other, maybe in that case you will face some difficulty, but otherwise you will not face any difficulty. Now let's move on. A parallel plate capacitor is charged by connecting a 2-volt battery across it. It is then disconnected from the battery and a glass slab is introduced between the plates. Which of the following pairs quantities decrease? Okay, so don't start calculating as soon as you read the question. It is mentioned that battery was connected. Okay, then what they have done, it is then disconnected from the battery. So after disconnection, they have introduced the glass slab. Okay, so initially the capacitor is charged. When the capacitor is charged fully, then they have introduced the glass slab. Now remember that when the capacitor is fully charged, initially the charge in that capacitor will not decrease on its own. Okay, charge will remain constant because battery is disconnected, but what all will increase? Increase will be capacitance. Definitely capacitance will increase. What will decrease? This will, everything will increase is capacitance will increase. What will decrease? Charge is same. We know that Q equals to CV, right? So if C is increasing, V has to decrease. V is decreasing. What else will decrease? Potential energy stored in the capacitor will decrease because potential energy is half CV square. So even though C is increasing, V is increasing. V is decreasing double time, that is square. So that's why potential energy is decreasing. Now let's see energy stored and capacitance. Capacitance is increasing, so this is not correct. Charge and potential difference, charge is constant, so this is also not correct. Capacitance and charge, capacitance increases, charge is constant, so it is also incorrect. Potential difference and energy stored, this is the correct option because potential energy is decreasing as well as energy stored in the capacitor is decreasing. Okay. Now, if a slab of insulating material K 4 times 10 to the power minus 3 meter thick introduced between the plates of a parallel plate capacitor, the separation between the plate has to be increased by 3.5 10 to the power minus 3 meter to restore the capacity of the original value. The dielectric constant of the material will be. Now there is a shortcut method. You can derive that shortcut method, or you can directly use that shortcut method. What is that? What was the thickness of the dielectric? Dielectric thickness is 4 times 10 to the power of minus 3. What is the thickness of the air gap that we need to add to restore the capacitance? That is 3.5 times 10 to the power of minus 3. Okay, this should be equals to 4. What is the thickness of the dielectric? Divided by what is the dielectric constant? Dielectric constant we are trying to calculate. So this is the value. Okay. Now this is the formula to calculate directly from for this kind of questions. Okay. If you want how this formula came, I can explain it, but this is the shortcut method. You should remember that delta T, that is delta in the thickness, is the thickness of the dielectric divided by K. If you remember this formula, your life will be easy. Okay. Now 0.5 times 10 to the power of minus 3 equals to 4 times 10 to the power of minus 3 by K. Minus 3 cancels, so K 4 divided by 0.5, that is 8. So 8 is the answer. Okay. If you have any doubt, you can mention. If you want explanation for this formula, mention that in the comment. I will explain in a separate video. Okay. Now, 8 drops of mercury of equal radii combine with the big to form a big drop. The capacitance of a bigger drop compared to the each smaller drop is. Now, this part is no longer part of your KCET syllabus, but you should know that capacitance of a sphere is directly proportional to the radius of the sphere, and 8 drops of mercury, when they combine, they will form a bigger drop which has a radius double that of the initial small drops. So each of the small drops will have a capacitance, say C. Okay. Each of the capacitance has capacitance C, and the bigger one will have a capacitance 2C. Okay. So it is 2 times, because radius is twice that of individual capacitor, so it will be 2C. 6 microfarad in a circulation process of potential difference of 1.5 kilovolt, a large number of 2 microfarad capacitors in which can withstand a potential difference of not more than 500 volt are available. The minimum number of capacitors required for the purpose is. So what is the question? Question is that we have to achieve 6 microfarad, okay, in as equivalent capacitance, but we have many 2 microfarad capacitors. We do not have exact 6 microfarad capacitors. But the catch is that each capacitor can maximum withstand 500 volt. So it is not so easy. If they are rating also 1.5 kilovolt, then we can simply add 3 to 2 microfarads in parallel. Okay, then we can say, okay, this is our combination. But if you see, each of them is able to withstand only 500 kilovolt. Now we know that in parallel combination, each of them will get the same voltage. That is, if I apply say 1500 volt, 0.5 kilovolt means 1500 volts, right? So if I apply 1500 volt, each of the capacitors will immediately burn, because it is much higher, 3 times higher than their rating. So what we have to do? First, we have to find a combination which can withstand the 1500 volts. So that is our first target. Once we can do that, then we can find the capacitance, then we put accordingly, and we can find how many lines we need. Okay. So first we have to find the capacitor which can withstand 1500 volt. Okay. What is that? So we know that in series combination, the potential actually divides across the capacitors. Now each of the capacitors are 2 microfarad, so it will be divided equally. So how we can do that? If we add 3 capacitors in series, then what will happen? It can withstand the 1500 volt, right? So each of them will have 500. This will have 500. This will have 500. This will also have 500. Now add them, you will get 1500. That is 1.5 kilovolts. So when you connect these 3 capacitors, now they can withstand the exact amount of voltage. Now voltage is sorted. Now we have to find the equivalent capacitance for this combination, and then we will decide how many we need in parallel to find the 6 kilovolt, right? So 6 microfarad, sorry. This is the 3 capacitors in series, each of them are same. So the equivalent capacitance of this circuit is 3 capacitors each equal, okay, in series. The equivalent capacitance will be capacitance of any one of them divided by the number of capacitors. Okay, so this is the capacitance for one row. So one row will have this many capacitors. Now suppose we have such rows, there are n number of rows. Okay, for 2 for example, 2 microfarad capacitors, we needed 3 rows, right? How we calculated that? 6 was our target divided by the capacitance of each row, right? But that was not able to withstand the 1.5 kilovolt that we needed. Now we have found a capacitor which can withstand 1.5 kilovolt. So now what we have to do, how many rows we need? Suppose n rows is needed, so n will be 6 divided by 2 by 3, that is 6 times 3 divided by 2, that is 9 rows. Now 9 rows, 9 such rows is needed. Now how many capacitor is there in one row? In one row we have 3 capacitors, right? In one row we have 3 capacitors. So 3 capacitors are there. This is the equivalent capacitor. But when we are connecting them, we are connecting 3 capacitors each row. So total number of capacitors will be 3 times 9, that is 27 capacitors. So minimum number of required capacitor is 27. It is not 3, it is not 6, it is not 9 or not any other value. It is 27 capacitors is needed. This is a very trick question, but simple question. Okay, it's understanding question. If you understand that concept, you will be able to answer it. If you are not able to understand the concept, you will not be able to answer this. In figure, charge on the capacitor is plotted against the potential difference across the capacitor. The capacitance and energy stored in the capacitor are respectively. So in this figure we have shown a figure where this is the charge stored in microcoulomb and this is the voltage. So when the voltage was 10 volt, okay, the charge stored was 120 microcoulomb, right? Now what they have asked you? They have asked you to find the energy stored as well as the capacitance. Now capacitance, we know that Q equals to CV, right? Q is 120 micro. I am not breaking the micro because that will maybe cancel or may not cancel, but we know that micro for capacitance it is well possible that it is microfarad. So 120 I am keeping it here. C we are trying to calculate, voltage is 10 volt. Okay, so C is basically 12. Now since it was microcoulomb, it will be microfarad. So capacitance we have calculated. Now we have to calculate the energy. Now the potential energy is given by half CV square, right? So half C is already calculated 12 microfarad, V is 10, that is 10 square is 100. Okay, so it will cancel 12 microfarad and 600 microjoules. That is correct option is option B. So let's move on. The figure gives the electric potential as a function of distance through 4 regions on x-axis. Which of the following is true for magnitude of the electric field E in this region? Now if you see this diagram, they have given you this diagram and they asked you in which case electric field is maximum, which case electric field is same. Now if you see, we know that electric relationship between electric field and potential is E is equal to minus dV by dx, right? So we generally do not use the negative sign, but in this case we have to use the negative sign to find the maximum change. Now if you see, in this case the potential is constant. Potential constant means dV, V is constant, so dV by dx is 0. That means electric field is 0 here. If you see here, potential is increasing from 2 to 4 in 1 second. So electric potential is increasing from 2 to 4 in 1 second. So dV is 2, dx is 1. So EB is 2, right? EB is minus 2, right? Now if you see again, here potential is constant. Potential constant means electric field is 0. So EC is 0. Now here potential is decreasing from 4 to 0 in 1 second. So 4 to 1, so dV is 4, dx is 1, and it is decreasing. Decreasing means a negative of negative, that is double negative. So ED will be 4 by 1, that is 4. Okay. Now what all the option is correct? Let's look into the given option. So EA and EC is 0. Even though they have not mentioned that, but they have said EA equals to EC. So only one given option is given where EA is equals to EC is given. All other options, they have not mentioned anything equality about EA and EC. So EA is equals to EC equals to 0 is also correct, and EB is less than ED. EB is minus 2, ED is 4. So obviously EB is less than ED. So correct option is option D. So be careful. This is a very simple question. You don't need to calculate this. If you understand that, okay, this is only changing by small amount, this is changing by big amount, this is positive, this is negative. This is changing from positive to positive, this is changing from positive to 0. That is, its slope is will be positive in the term because E is negative of that of change of electric field. Okay. Now, another question, similar question came in NEET as well a few years back. Okay. The figure shows 3 points A, B and C in region of uniform electric field E. The line AB is perpendicular and BC is parallel to the field lines. Then which of the following holds good? VA, VB and VC represent the electric potential at point A, B and C. Now, this is an uniform electric field but not constant electric field. So, in case of uniform electric field, we know that as we are moving in the direction of electric field, the value of electric field decreases. If electric field decreases, potential also decreases. So, and when we are considering the same plane, this is called equipotential surface. So, equipotential surface means all points are at equal potential. So, VA must be equals to VB and they both should be greater than that of VC because VC is going in the direction of electric field, right. So, VA is equals to VB and they are going to be greater than VC. So, correct option is option D. Okay. Simple problem, nothing difficult. A dipole of dipole moment P and moment of inertia I is placed in an uniform electric field E if it is displaced slightly from its stable equilibrium position. The period of oscillation dipole is, now we know that the time period of oscillation for a dipole when it is slightly rotated in a dipole electric field is given by 2 pi root over of I by PE. Okay, I by torque. So, if you remember this formula from the first year, when you are applying a torque and it is rotating, the dipole moment is given by, time period is given by this formula. Okay, here torque is PE. Okay, it is aligned. So, PE sin theta, theta is, they are 90 degrees. So, that means sin theta will not come here. So, it will become PE. Okay. Now, this is the formula. So, from there we can write this as not this one. Yeah, this one they have made some mistake here.
It will be I by P. Okay, there's a mistake.
It will be I by P. Now, let's move on. The difference between equivalent capacitance of two identical capacitors connected in parallel to that in series is 6 microfarad. The value of capacitance of each capacitor is. So, same capacitors, two capacitors, okay, identical capacitors C and C, when they are connected in series, their equivalent capacitance is, as I told you while solving this kind of problems, that equivalent capacitance of two identical capacitors connected in series is C by 2 and in parallel is obviously 2C. They are getting added, right. So, now what is given is the difference between them. So, 2C minus C by 2 is given as 6, right, and they have asked you to find the value of the capacitor. Very simple. So, C take common, 2 minus half. Okay. So, 4 microfarad is the answer. Let us move on. Question number 15. A metal plates are separated by 2 centimeter. The potentials of the plates are 10 volt and plus 30 volt. The electric field between the two plates is. So, two metal plates are separated. The distance of separation is given. The voltage is given. Okay, one is minus 10, another one is plus 30. We know that electric field is minus dV by dx. Okay, here they have asked you to find the magnitude, they are not interested in finding the sign. So because they have given only, they have asked you to find the electric field between the plates. Now, so that's why we don't need to use this sign in this problem. So what we will do, we will find dV. So dV is, what is dV? 30 minus 10. Okay, that is 30 plus 10, that is 40 volt. Or you can do minus 10 minus 30 minus 40, both are okay. Okay, now dx, what is dx? Dx is 2 centimeter, that is 2 times 10 to the power of minus 2. Right, we know that whenever there is a centimeter, we have to use this factor to convert it into meters instead of complicated calculation of decimals. We will simply use 10 to the power, that is because that is easy to understand. So divided by 2 times 10 to the power of minus 2, 20. 20 times 10 to the power of 2, that is 20 times 100, that is 2000. Okay, so 2000 is the correct answer. Now another question. Now whenever you see this kind of question, don't think this is, they are all about Wheatstone bridge. This is not Wheatstone bridge. Okay, we will solve this question in this diagram itself. Okay, I am not going to use anything else. I will solve this question in the diagram itself, like you are supposed to do during your exam. So 100 picofarad, 100 picofarad. Okay, they are, as you are seeing, this is the correction. So but there is no gap between these two capacitors. So basically they are connected in series. So connected in series, whenever there is a connected in series, we know that equivalent capacitance is basically half of the equal capacitors. If they are half equal, 100 and 100 equal, so this must be 50 picofarad. Okay, the equivalent. Okay, once we remove this and this, we will get 50 picofarad. Now 50 and 50 is connected in parallel. If you see, this is they are connected like this, so that means they are connected in parallel. If they are connected in parallel, that means they will get added. So the equivalent capacitance will be 100. 50 plus 50, parallel means 100. Okay, so 100 from this side, that is A, and 50 here, that is B, this one. Okay, so now 100 and 50 are in series. If you see, they are in series, one after another. This is not parallel. So 100 and 50 are in series. That means the equivalent capacitance, two capacitors are in a parallel combination, series combination. So multiply by add is the final capacitors. Okay, simple question. Simple question. Keep it simple. Don't make it complicated. Now, a capacitor of capacitance C is charged by an amount Q and connected in parallel with an uncharged capacitor of capacitance 2C. The final charges on the capacitors are. So what was that? First, the capacitor was charged to a charge Q. Okay. Now the capacitor is removed and then it is connected to another capacitor of 2C. This was C, this is 2C. Now what is same across these two capacitors? What is same? Only thing that is same is the potential. Okay. Once the capacitors attain the equilibrium, that is no longer charges are exchanged. Suppose this is Q1, this is Q2. Okay, charges on these two capacitors are Q1 and Q2. At this point, they are at equilibrium. That means they are at equal potential. So what we can write is that charges, say Q1 is equal to CV and charges Q2 equals to 2CV, right? So this is for this capacitor, this is for this capacitor. Now initially only one capacitor was charged, so it had total charge Q. Only that charge is now redistributed because we are not connecting any external battery. So what all we can write? We can write that Q1 plus Q2 should be equals to the initial charge of the system, that is Q. Okay, because this charge is only we started with and that charge is only redistributed, right? So we have to put the value CV plus 2CV equals to Q, right? So 3CV equals to Q. Okay. Now we have calculated the voltage. Voltage is Q by 3C. Q by 3C. Now you can calculate the charge. Charge is Q1 is C times Q by 3C, that is Q by 3, and Q2 is 2C by Q by 3, C cancels, so 2Q by 3. So Q by 3 and 2Q by 3. So Q by 3 and 2Q by 3 is the correct answer. Simple. Simple problem, keep it simple, don't make it complicated. A particle of mass m and charge q is placed at a rest in uniform electric field E and then released. Its kinetic energy attained by the particle after moving a distance y is. So we have a charge here, okay, is placed in rest and it is applied across an electric field, constant electric field E. Okay, once it is released and it travels say a distance y, what is the kinetic energy of that particle? Simple problem. Initial potential say VA, final potential is VB. Okay, then the kinetic energy as usual is given by difference in potential VB minus VA times charge, that is the potential energy converted into kinetic energy. This is the potential energy lost. That same energy will be must be converted into kinetic energy, right? Or we can say delta V times Q. This is the formula. Always remember this, delta V Q is the kinetic energy. Now what is electric field? Electric field is delta V by delta L, dV by dl, right? Now here delta V is not given obviously, but delta L is given. Delta L is given when it traveled a distance of y, right? So distance y means delta L is y. So we can calculate delta V from this. So delta V is E times y, right? So delta V is calculated. We can find the kinetic energy. So kinetic energy Ek is Ey times Q or Q E y. So Q E y is the energy attained by this moving charge. Now let's move on to the next problem. A system of two charges separated by a certain distance apart stores electrical potential energy. If the distance between them is increased, the potential energy of the system may increase or decrease. Increases in any case, remains the same, decreases in any case. Now we know that potential energy of a system is K Q1 Q2 by R square, right? Now if both the charges are positive, if both the charges are same sign basically, if both the charges are positive or both the charges are negative, if you increase the distance, sorry, I made a mistake, it is not R square, it is simply R, okay, it's simply R, right? So if I increase the distance, if the charges are of the same sign, in that case what happens, the potential energy will decrease, right? So initially suppose K is 9 10 to the power of 9, Q1 is 1, suppose 1 coulomb and distance was 1 meter. So initially potential energy was 9 times 10 to the power of 9, sorry, 10 to the power of 9. Now if I increase the distance to say 3 meter, initially it was 1 meter, now I increase the distance to 3 meter. Now it will be 9 times 10 to the power of 9 divided by 3, so it will be 3. Now the new potential will be, so the potential energy is decreasing here, right? So potential energy is decreasing in this case. Now similarly, if one charge was say instead of +1, the last charge is now negative, okay, -1, then what would have happened? Initial energy was -9, final energy is -3. Now which one is greater? -9 is greater or -3 is greater? In the negative terms, lesser the number, bigger it is, right? So -9 is smaller and -3 is bigger. So in this case the potential energy is increasing. So if both the charges are of same sign, the potential energy will decrease. If the charges are of opposite sign, potential energy will increase. So it may increase or decrease based on the combination, right? It may increase or decrease based on the combination. Now, a mass of 1 kg carrying a charge of 2 coulomb is accelerated through a potential of 1 volt. The velocity acquired by it. Very important, interesting question. They have not given you any other thing. They have only said, okay, through 1 volt you accelerated a charge 2 coulomb, and then what is the velocity of it, right? So we know that the work done while accelerating through 1 volt is given by Q times V. Q times delta V, Q times V, since the potential difference itself is given as 1 volt. So QV, and this should be equals to the kinetic energy. Kinetic energy is half m V square. Here this V is potential. Let's not get confused. This is capital V, that is this, and this is velocity that we are trying to find. Q is 2 coulomb, V is 1 volt, okay, half, mass is 1 kilograms times V square. Okay, so V square is basically 2 times 2, or V equals to 2 meter per second. Okay, this is the correct answer. So this will be 2 times, this 2 will go up, everything else is 1. So don't worry about it. Simple problem. Now, this is another little bit complicated problem. Let's see here what is said, that the arrangement of capacitor as shown in the circuit, the effective capacitance between the points A and B, each capacitor. Okay, so this is also not difficult problem. It is same as the problem that we have solved, that is the concept of Wheatstone bridge. If you see this, you can consider this, you can consider one arm of the Wheatstone bridge. This you can consider another arm of Wheatstone bridge. This you can consider one arm of Wheatstone bridge. This you can consider another arm of Wheatstone bridge. Now these 2 points are same potential. So instead of considering this capacitor here, you can consider this capacitor here, right? And for the same reason that I have explained, they are all 4 microfarads. So basically this is an equilibrium condition of a Wheatstone bridge. So here you can consider this capacitor is not connected, that is in central capacitor. You can remove the central capacitor, right? So this is simple Wheatstone bridge calculation, that these 2 are connected in series, these 2 connected in series, and the final thing is connected in parallel. Now as I said, 2 capacitor of equal capacitance connected in series, that means the equivalent capacitance is half of that. So it is 2 microfarad, right? This is 2 microfarad. Right? And once they are connected in parallel, the equivalent capacitance is 2 plus 2. 2 plus 2, 4, right? We always say don't do 2 plus 2, 4, or it will be 2 plus 2, 4. So here we got 2 plus 2, 4, right? There is a saying 2 plus 2, 4, right? So we have done 2 plus 2, 4. The work done to move a charge on a equipotential surface. I discussed this while discussing the chapter. The work done to move a charge in equipotential surface is 0. Okay. 2 capacitors of 3 microfarad and 6 microfarad are connected in series, and the potential difference of 900 volt is applied across the combination. They are then disconnected and reconnected in parallel. The potential difference across the combination is, so initially what is happening is that they are connected to a battery of 900 volt. Okay. Suppose the charge is flowing in series combination, charge is constant. As we know that the charge, whatever it is going through it, it has to come back to the battery. So if Q charge is passing through this capacitor, okay, suppose this capacitor is C1, this capacitor is C2, voltage is different. This is V1, this is V2. Okay, initially C1 V1 equals to C2 V2 because charge is same, right? Charge is same on both of them. So Q equals to C1 V1 C2 V2, right? And also we know that the potential is V1 plus V2 should be equals to 900, right? These are the known information. So what we can do, we can calculate V1 V2 and then we can calculate the charge Q. Now once they are connected in parallel, there is no external battery involved here. In this case, the total charge will be redistributed. So total charge will be redistributed till they achieve a same constant voltage. Till they achieve same constant voltage, right? In case of parallel combination, the voltage is same. In this case, charges will be different. In this case, suppose this charge is Q1, this charge is Q2, but total charge will be conserved. In this case, each of them has QQ charges. So total charge is 2Q in this system. Here it is Q1 plus Q2, right? So let's first start with this information, that what will be the value of Q. So C1 V1 is equal to C2 V2. Let's find the value of V1 and V2. So C1 is 3 times V1. V2 is C2 is 6. V2 we don't know. So V1 equals to 2V2. Now put this value here. 2V2 plus V2 equals to 900, or 3V2 is 900, or V2 is 300. So if V2 is 300, V1 is 2 times 300, that is 600. Now what is the charge on each of the cases? In this case, charge on each of the capacitor is say this one, C1 V1. Okay, C was 3, Vn was 3, whatever unit is. We are not considering unit as of now. We are only interested in finding the capital Q. Now, in this case, what is the charge? Q1 is equals to C1 V and Q2 is equals to C2 V. We do not know the value of V in this case, but we do know that Q1 plus Q2 should be equals to the initial charge of the system, that is Q plus Q, that is 2Q, right? Now if you put the values, C1 plus C2 times V. Now we are trying to find, so let's say this V is V dash. We are trying to find this V dash only. So V dash 2Q. Now let me remove some of the not important parts. That is this part. What will be the value? V dash is equals to 2Q divided by C1 plus C2, okay, or equals to 2 times 1800 divided by 3 plus 6, right? 3, 6. So 2 times 1800 divided by 9. So it is 400. Okay. Any doubt, you mention in the comment below. Okay. Let's move on to the next problem. 24. A system of two capacitors of capacitance 2 microfarad and 4 microfarad connected in series across a potential difference of 6 volt. The electric charge and energy stored in the system are similar to the previous problem. Very similar to the previous problem. Same thing. Two capacitors are connected in series and they have asked you to find the energy and the charge stored in the system. So electric charge is capital Q, right? Now let's see how much charge it is stored. So we know that Q is equals to C1 V1 equals to C2 V2, right? Any one charge is sufficient in this case. Now what is the Q1 Q2? C1 is 2, okay, and V1 we don't know, but we know that this is actually equals to 4 times V2. So V1 is equals to 2v2. Same as previous problem. Only thing is the final result will be different. But if you start with the initial relationship, same as previous problem. Also, we know that V1 plus V2 should be the total potential supplied, that is 6 volt. Now V1 is 2V2 plus V2 is equal to 6, or 3V2 equals to 6, or V2 equals to 2 volts. So we have calculated the potential for second capacitor. So charge will be, let me use this one only, C2 is 4. So 4 times 2, that is 8. Now microvolt means microcoulomb charge will be, microfarad means microcoulomb charge will be stored, and total energy will be half C1 V1 square plus half C2 V2 square. This is the total energy of the system. While calculating the charge, you can calculate any one of the combination. But if you see, you don't need to do anything else, because in this combination only one has 8 microcoulomb charge. So you can check if this is coming out to be 20 microjoule or 24 microjoule or not, and mention in the comment. Okay, but if you see all the options in this, all the options charges are given different. So if you calculate the charges properly, then you don't need to worry. So there is a hint, there is a suggestion. If you see all the options are given, if suppose energies are different, then you go for energy. If the charges are different, you go for charge only and leave it there. Okay, otherwise don't solve the entire problem. You don't need to solve the entire problem if you are getting the answer from the first part of the question itself. Now question number 25. 2-point charges A equals to plus 3 nanocoulomb and B equals to plus 1 nanocoulomb are placed 5 centimeter apart in air. The work done to move the charge B towards A by 1 centimeter is. So initially charges are placed, 2 charges, plus 3 nanocoulomb and plus 1 nanocoulomb. Initially they were placed at a distance 5 centimeter, right? Now what you have done, you have now moved this charge towards this charge, say by 1 centimeter, right? So you have to calculate the work done. So what is the initial potential energy? Initial potential energy, not potential, sorry. Initial potential energy of the system. Initial potential energy of the system is K Q1 Q2 by initial R, that is R1, say, and final potential energy UF is K Q1 Q2 by R2, right? Now both of them are positive. You are reducing the distance, that means final is more. So the work done is delta U. Work done is delta U, means UF minus UI. That is, if you take K Q1 Q2 as common, because that is common for both of them, you will get R1 by R2 minus 1 by R1. Okay, so what you have to do? Work done, K is 9 times 10 to the power of 9. Okay, Q1 is 3 nanocoulomb, Q2 is 1 nanocoulomb divided by, oh, there is no division here, only thing is you have to calculate, along with this you have to calculate this value. So times 1 by 4 minus 1 by 5. Let's see this value. So 1 by 4 minus 1 by 5, that is 25 minus 4, that is 1 by 20. Simple. And they are in centimeter. Centimeter means you have to convert it into meters. Minus 2, that's it. Okay, it will be there in the denominator, times 10 to the power minus 2 times 10 to the minus 2, or you can calculate everything and put one extra here. So you can write this as 20 times 10 to the power of minus 2. Now 1 10 to the power 9 will cancel, right? Plus 9 minus 9. Now you have to check what is the answer. 3 to 9s are 27. 27. Now if you see here 1 0 we can reduce. 10 to the power of minus 9 1, this 9 will stay. Here we can reduce 1 0. So 2 times 10 to the power of minus 1. Right? Now if you cancel this, you will get 27 13.5. So 13.5 times this will go up and it will become positive. So 10 to the power of minus 8. Now if you see, so all the options are given in 10 to the power of minus 7. So you have to reduce one more 10 to the power. So you have to put one more decimal. So 1.35 times 10 to the power of minus 7. Okay. So 1.35 times 10 to the power of minus 7 joules. Okay. Now, the minimum value of effective capacitance that can be obtained by combining three capacitors of capacitance 1 picofarad, 2 picofarad and 4 picofarad. So when capacitors are connected either in series or in parallel, the lowest possible capacitance is when they are connected in series. Okay, remember this, when they are connected in series, the lowest possible capacitance is possible. So we know that C equivalent 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3. These are old question, very old question. So these are very simple. So 1 by 1 plus 1 by 2. You will not get this kind of question in nowadays. But still, since it was asked, maybe now they will ask the same question in your board exam. So don't ignore. And most importantly, once you calculate, because it is 1 by CEQ, don't forget to take the reciprocal and find the final answer. To find the final answer, you have to take the reciprocal, that is 4 by 7. This is the correct answer. So 4 by 7 is the lowest possible value. Don't get confused and answer 7 by 4. If you answer 7 by 4, everything will be gone. Okay. Nature of equipotential surface for a point charge is, so point charge is given. So nature of equipotential surface will be concentric spheres. As we said, it will be three-dimensional diagram. It is not two-dimensional, so not circle, not ellipsoid. Okay, only thing is sphere with charge at the center of the sphere. It is not on the surface. It is not any other point. Okay. A particle of mass 1 gram and charge 1 microcoulomb is held at rest on a frictionless horizontal surface at a distance 1 meter from the fixed charge 2 microcoulomb. If the particle is released, it will be repelled. The speed of the particle when it at a distance of 10 meter from the fixed charge. Same question, similar concept you have solved, that kinetic energy is basically Q times delta V. Okay, so first we will calculate, or in this case kinetic energy is initial potential energy minus final potential energy. Okay, so delta U. You can use both of the thing, everything will get the same answer. Okay, because there are two system of charges, instead of using potential we are using delta U, but you can use Q delta V as well, but both are giving you same result. So delta U initially, so initial U initially is Ui is when they are kept at a distance of 1 meter. So K Q1 Q2 by 1 meter, that is K Q1 Q2. Okay. Now final potential is K Q1 Q2 by 10 meters, right? So K Q1 Q2 by 10. Now if you see, in this case both the charges are positive and you are allowing them to move. That is, the field is doing the work. That's why the potential difference, if you are doing UF minus UI, then you will get a negative value. But since system is doing work, we are not worried about sign. We are only worried about the difference in energy. So what we will do, we will minus from bigger value to the lower value. So K Q1 Q2 by 10. So it will be K Q1 Q2 1 minus 1 by 10. That is 9 K Q1 Q2 by 10. Now this is equals to half mv square. Right, half mass is given 1 gram. 1 gram means 10 to the power of minus 3 times v square equals to, now let's put the values here. 9 K is 9 times 10 to the power of 9. Q1 is 1 microcoulomb, that is 1 times 10 to the power of minus 6. Q2 is 2 millicoulomb. 2 millicoulomb, that means 2 times 10 to the power of minus 3. Milli is minus 3. Micro is 10 to the power minus 6. Remember these values. And this is 10. Now, what we have to do, we have to think, okay, 10 to the power of 9 here, minus 6 minus 3. So, it is minus 9. So, we can simply cancel all the 10 to the powers. 10 to the powers thing is done. Right. Now, we have only one 10 to the power of minus 3 on our left hand side. If you take on the right hand side, it will become positive. So, V square equals to, this 2 was division, it will be multiplied, right. 2 times 9 times 9, okay, times, there was one more 2 here, times 10 to the power of 3 whole divided by 10, right. Now, what you can do, you can cancel this 10 and make this 3 as 2, right. One of the 10 will cancel. Now, if you see, so V will be, so there are, you have to take the square root. So V is square root of everything. So if there are 2 2's, that means only 1 will come. If there are 2 9, only 1 will come. If there are 2 10's, only 1 will come. That is the meaning of square root. So 2 9 is 18, 180. Right? So 180 is the answer. Simple. Use the mathematics, calculate square root. Okay, reduce as much as possible without using the variables. At the last moment, you use the variable so that your calculation is neat and clean. Now 29th, 4 metal plates are arranged as shown in the capacitor. Capacitance between X and Y are. So they have a distance of D. So these distances are D. All the distances are D. And area is A. So what is the capacitance for each capacitor? Say C. C is basically A by epsilon naught D. Okay, assume they are all air inside. There is no capacitance, dielectric constant. So K is value is 1. So A by epsilon naught D is the capacitance. Now, if you break this apart, you will see this capacitor is alone, right? So X is on this side. So X is here. You have to try to visualize this kind of diagram. This is very common in JEE exam, in NEET exam also this kind of question is very common. Now these two are, if you see, this is connected to this capacitor, right? So this end is, both of this end is connected to this end, right? So what we can draw is, instead of drawing like this, we have to draw them like this. This capacitor as well as this capacitor, both are connected to this. So both are connected to this side from this side, and both of them have another common port, that is Y. Okay, so these two ends, basically this is the meaning of these two are connected. So these two are connected. This is connected, this lower capacitor is connected, and the upper capacitor is connected from this side. So both are connected from one side to this end, and other capacitor is connected to Y. So this is the basic fundamental of this diagram, where you are analyzing this kind of diagram. So whenever they are connected like this, that means they are interconnected. Now you have to decide how they are parallel. That is, you have to determine. So basically this means parallel. except few case where even though it is appearing to be parallel, it is not. I will share some example in future, but for now, so this is say C, this is C, this is C, and they have asked you to find the capacitance, right? Equivalent capacitance. Now these two are equal capacitance, they are connected in series, parallel. Parallel means they just get added. So this is C, this is 2C, C plus C, 2C. So equivalent capacitance is two capacitors only. C into 2C divided by C plus 2C. Right? This is the shortcut when only two capacitors are involved. For 3, you cannot use this formula. So 2C square divided by 3C. One of the C cancels. So 2 by 3C. So 2 by 3C means C is this. Right? So if you put the value, you will get 2 by 3 times epsilon naught, A by epsilon naught D. Right? So 2A by epsilon naught D. Sorry, I made a mistake. The capacitance will be this. Epsilon naught A by D, right? So epsilon naught A by D means epsilon will be in the numerator, not in the denominator. Sorry, my mistake. Right? So here, from here we can see the correct answer is option C, 2 epsilon naught A divided by 3D. This is the correct answer. Let's move on. Last problem, I am going to solve only 30 problem. I will give you some homework problem, and I am not going to solve those homework problems, especially after solving 30 questions. If you are observing all those 30 questions, you should be able to answer those 4 questions. If you have any doubt and queries, you can mention that in the comment. We can discuss in the comment, and I will personally check and answer in the comment as well. So now question number 30, a parallel plate capacitor is charged and then isolated. The effect of increasing the plate separation on the charge, potential and capacitance respectively are. So what they have done, they have charged the capacitor to the maximum, right? Now charge is conserved. So once the capacitor is fully charged, what they have done, they have just simply increased the plate separation. They have slowly increasing the plate separation, and they have asked you what will be the effect. Now if the charge was Q, the same charge will stay here. Charge will remain constant. Charge is conservative, right? Now what else? Charge potential. Potential was suppose V. Okay, potential and capacitance are interrelated with charge. Now capacitance, what will happen to the capacitance? Capacitance, we know that K epsilon naught A by D, right? So if you increase the separation, that means D is increasing, so capacitance will decrease, right? So capacitance will decrease. Suppose this one is C1 and V1. So capacitance is C2 V2. Capacitance decrease means we know that Q is equal to CV. Now capacitance is decreasing. That means voltage has to increase to maintain the same amount of charge. So charge is constant, then potential is increasing and capacitance is decreasing. Okay, so correct answer is option B. Now even if you are confused, only two combination can help you, that is constant and decreases, and then there will be only two options. So you have to either choose increases and decreases. For that you have to compare and decide that okay, potential is increasing. Okay, there is one more property that you should remember. Higher capacitance means it will allow you to store same amount of charge at very low potential, right? That was the property we discussed during capacitance chapter. So if you are decreasing the capacitance, that means its potential has to increase to maintain that amount of charge. Now charge is constant, charge is conservative, so that's why Q will remain constant up to certain limit, up to breakdown limit. Once the breakdown is reached, then the charge will start coming from positive to negative charge or negative to positive charge, and they will reduce each other, but total charge will remain constant, right? Now there are some homework question number 31. You can take a screenshot, you can pause the video, read the question, answer it, and mention the answer in the comment below. I am not going to solve PYQs questions. This is from previous year questions, so I am not going to answer this during any of the lectures or anything. But if I give the same question during our lecture, that will be answered. Okay, but these are not going to be answered. You have to answer these questions on your own. Homework question number 2. Again, pause the video if you want, take a screenshot and then try to solve it. Mention the answer in the comment below. If I see any answers, anyone answers the questions, mention the question number. Also, I am seeing many of you are answering just option A, option B, option D. Either mention the time or you mention the question number. Okay, that is the ideal way when you are answering a question. Homework number 3. Pause the video, take a screenshot and answer this. Okay. Homework number 4. Again, pause the video, take a screenshot, answer the question and then mention the answer in a comment. Okay. Or you can simply pause the video, take the solve it on your own, then you run the video as you want. Now, so I request you to join our WhatsApp channel. Link will be given in the description. Also, if you have not yet subscribed to our channel, YouTube channel, please do subscribe. We are doing a lot of things. We are focused on KCET. We are focused on a lot of other subjects as well, not only in physics. So don't forget to subscribe to our channel. Thank you.